On the left column, we have examples of several quadratic functions. On the right column, we have several quadratic equations. What do you think the difference is between a quadratic function and a quadratic equation? Because they're both quadratics, we know that each is going to have a degree of 2, but you may notice that functions are equal to a variable, whereas equations are equal to a number or a numerical value. That means that on a function, I can substitute any value in for x. So think about when we made our table of values, and I can generate the corresponding y coordinates. For an equation, if it's equal to a specific value, such as the first one is equal to 0, we have to figure out what is x equal to, that when we substitute it into this equation, we're going to get a value of 0. Or down here, what is x equal to, that when we substitute it into the right-hand side, in the place of x, we will get a value of 6. We just finished working with quadratic functions. I'm now going to replace this variable with a numerical value. So in this particular example, let's put a 0 in for the place of y. Now picture the graph. So on the y-axis, we're looking for where is that value 0, and we know that y is 0 right here. So if we go over to where that parabola is going to cross, we can see that in this particular example, that's going to be the x-intercepts. So y is now a specific value of 0. On the y-axis, 0 is right here, so our parabola crosses when y is 0 at those x-intercepts. Those x-intercepts are also sometimes called the zeros of the function. So we're looking for the values of x when y is equal to 0. They're called the roots of the equation, and sometimes it's going to ask you just to simply solve the quadratic. So all of those are synonymous terms where we're looking for those x-intercepts. Now our quadratic can have 2 solutions, 1 solution, or 0 solutions. If our parabola crosses the x-axis twice, we say we have 2 distinct real roots. So distinct just means that those 2 x-intercepts are going to be different values. If our parabola has 1 solution, it means that that vertex is going to lie on the x-axis and open either down or open up. We say we have 1 real root, so real just meaning it belongs to the real number system, or sometimes we'll also say we have 2 equal roots. So in this particular case, we have 2 distinct roots, different values for x, 2 equal roots, both of them have the same value. Or we can also have 0 roots. If our vertex is above the x-axis and our parabola opens up, or if our vertex is below the x-axis and our parabola opens down, we will never cross that x-axis. So we have no real roots. We do have 2 imaginary or complex roots, but no real numbers. Is that we can get the values of those x-intercepts. Today we're going to focus on how to do it by graphing using our graphing calculator. So the first thing we're going to do is go into y equals, and we're going to enter our equation. So we're going to go x squared and then plus 2x, and then make sure you do minus 24. Now, my window is going to just be the default settings. I'm going to leave it like that for right now, and we're going to go to the graph. Now, we do want to be able to see where it's going to cross the x-axis at, and even though I can't see the vertex down here, I can see those x-intercepts. So if you wanted to, remember, window, we want to take that y-axis, and I want to move the minimum down. So let's maybe try negative 20. And then if I'm going from negative 20 to positive 10, let's maybe adjust our scale and put 2 in there. We still can't quite see it, but you get the idea. Okay, so to get those values, we're going to go second function, trace, and we want 0. So those zeros are the x-intercepts. Now, the calculator prompts you. It says, are we to the left of that intercept? Because there's 2 in this question, we have to do them one at a time. And right now, this is the coordinates of where my cursor is. So I'm at 0, negative 24. So my cursor is right down here. I can only move the arrows left or right. As soon as I go up or down, it takes me off the parabola. So only going left or right. If I'm going to start with this x-intercept, we're going to go to the left, and we can see these values now changing. So we're going to keep moving here, and you should be able just to hold it down. Okay, so what you want to do is imagine there is a vertical line passing through that intercept. We are now on the left of it, so you want to get fairly close, and then we're going to press enter to say to our calculator, yes, we're on the left. Now our calculator says, are we on the right? So again, imagine that vertical line. If I'm to the right, I'm going to be below that x-axis. So as soon as we have a negative y coordinate, we know we're going to be below there, so we're going to press enter. And you're going to see at the top of your calculator these two little arrows. Your calculator now says, do you want me to guess for the value of that intercept in this range? So one more time, we're going to press enter to say yes. And our first x-intercept has a value of -6. Now we have to do the second one. So we're going to go again, second function trace. We're going to choose 0, number 2, 0, and the calculator says, are we on the left? So again, you have to imagine that there is a vertical line passing through that x-intercept. If I'm to the left of that, I'm now going to be below the x-axis. So I still need to have a negative y coordinate. So I'm going to move my cursor over here until I'm close and I can see that it is negative. So I'm going to press enter. Now it says, are we to the right? So imagine that vertical line. If I'm to the right, I'm going to be above the x-axis, so my y is going to be positive. I'm going to press enter to say yes. And then my calculator says, do you want me to guess that value within there? And that is where our intercept is going to lie. So we're going to press yes. And we have a second value of 4. So in this particular question, we have two distinct real roots. These are the values of those x-intercepts. And then we can always check to make sure that these will in fact satisfy this equation. So if I put a -6 back in for x, -6 squared gives me 36. 2 times -6 is -12. So 36 minus 12 is 24. Minus 24 gives me a y value of 0. So we know that this will be one of those x-intercepts. And then we can do the same thing. If I substitute a 4 in the place of the x, 4 squared is 16, plus 2 times 4 is 8, is 24. Minus 24 will give me a y value of 0. Because both of these are integers, they are what we call integral roots. Try another one. So we're going to begin by entering this function into our calculator. So we have 0.15 x squared, and then plus 0.5x, and then make sure that you press -6. If you accidentally press the negative, your calculator is going to give you an error message. I'm going to go back into the window and just reset it to the default settings, and then we're going to graph this so I can see those intercepts. So let's try this again. Second function trace. Number 2 zeros is what we're looking for. We're going to start with this one on the left. So we're going to take our cursor and we're just going to hold it down and we're going to slide it over there until we are on the left. So again, you're imagining there is a vertical line crossing through that intercept. My cursor is now to the left of it, so I'm going to press enter. Then it says, are we to the right? So there's a vertical line going through here. If I'm on the right, I'm going to be below the x-axis. I want that negative y value. So we're going to slide over here, press enter, and then as long as we're close, so our calculator is going to be looking within there for that value. That is where the intercept is. So we're going to press enter. And this time we have that particular value for our x-intercept. Now we're going to do this one more time. So we're going to go second function trace. Number 2, and again, you're imagining now we're doing this one, there's a vertical line. If I'm to the left, I'm going to be below the x-axis. I need a negative y coordinate. So we're going to hold our cursor down until we slide that cursor over. And we want to have a negative value, so we're going to press enter. And then imagine that line. If we are to the right of that line, we need to be above the x-axis. So we need a positive y value, so we're going to hit enter. And then do you want the calculator to guess within that range? Enter, yes we do. And there is our second value for the x-intercept. Now, if you wanted to verify this one, so right now my calculator has that 4.87 value in there. I can go second function quit, and then I'm going to take that value, I'm going to go store as x. So it's going to take that answer and it's going to enter that 4.873, etc. Now we can see that on the graph, it cut off the number of digits after the 6. That number actually keeps going even further from here. So this is an irrational root. That's just as many digits as the calculator can display. So I'm going to now enter this function. So we're going to go 0.15 x squared and then plus 0.5x. minus 6, and we should get a value of 0 if it's an x-intercept, and we do. And again, you could do that after the first one as well, just to verify. All right, if we see something like this, in order to enter it into the calculator into that y equals, I first want to get everything over to one side. So I'm going to subtract 7 to bring that right-hand side to 0, and I'm going to do the same thing over there on the left to keep it balanced. And now we can go ahead and enter that 3x squared plus x minus 7. We're going to go ahead and graph this, and then same thing, we're going to go second function trace, number 2, and we're going to scoot the cursor over here so that we're on the left, enter, so that we are on the right, enter, guess. And again, you can verify that. Second function trace, 0. Now this time we're going to do the one over on this side, so I'm to the left of that, enter. We're going to go up so that we are above the x-axis, enter, and there is our second x-intercept. First way that we can solve something like this is to set the equation equal to 0 and then graph it. There's another way that we can go about this. So if we have something really complex and we don't necessarily want to rearrange it, we can just leave the left side as is, enter it into y1 into our calculator, and then enter whatever happens to be on the right side into y2. So for example, I'm going to go into y equals, I'm going to put in the left side and the right side, and then when we graph this, y equals 7, that's just a straight horizontal line that's going to cross the y-axis at 7 right there. So then if we want to find those values, we're looking now for what is the value of x where those two graphs intersect. What is the value of x when y is now equal to 7? So y is equal to 7, what are those x values? So we're going to go second function trace, and then remember from last year, intersect is number 5. So I'm going to press number 5. And then our calculator prompts us, are we on the first curve? So we're going to move close to where those two graphs cross. And as soon as I press enter, you can see that cursor is going to jump. So I'm going to press enter to say yes. Are we on the second curve? Enter. Do you want me to guess? Enter. So we're just going enter, enter, enter. And you can see that the value of x where those two graphs cross is the same value we would have gotten when we graphed that one and got the x-intercept. And now again, second function trace. And we're going to choose number 5. We're now looking on this side where those two graphs intersect. So we're going to move our cursor over so we're close. Are we on the first curve? Enter, enter, enter. And you can see there again, we get the same value. Okay, so let's take a look at how to apply some of this. We have a skateboarder who's jumping off a ledge at a skateboard park, and his path is modeled by this particular function. H, we're told, represents the height above ground. D is the distance he is from the ledge. Both of those are measured in meters. We have to take this quadratic function and write a quadratic equation to represent where the skateboarder is going to land. So the first thing we always want to do when we see something like this is to draw a sketch, label the axes with the information they give us so that we can visualize what's happening. So we know that in place of the y, we have the h-axis. This is the height. We know in place of x, we have d. So this is how far he is from the ledge. This is in standard form. Standard form tells me two things. I know that my y-intercept is 1.5, so that means that I am 1.5 meters above the ledge, and actually we can go ahead and fill the units in here as well. I also know that my parabola is opening down because a is negative, so that's how I know it's going to look something like this. Now, where the skateboarder lands, he's going to land on the ground, so we're looking for h is going to be 0. So I'm going to keep this function and I'm going to replace the h of d when we have a height above ground of 0 meters. The second thing we need to figure out is what distance from the base of the ledge is that skateboarder going to land. So this is the ledge where he starts off and he's going to land here. So I'm looking for this x-intercept. Now we know that there's going to be another x-intercept over here, but that is going to give me a negative distance. It's behind where he originally jumped. So it is the x-intercept x-intercept on the right that I'm looking for. Go ahead and enter that into my calculator. And then when I take a look at the graph, I can see that even though that's okay, I want to adjust my window, and I'll leave a link in the description box below if you can't remember how to adjust the window. Just to zoom in on that graph a little bit more, I'm going to change both the x and the y-axis so that they go from -5 to +5 with a scale of 1. It's just going to zoom it in a little bit more closely. I'm looking for this x-intercept. So again, we're going to go second function trace. Number 2, we're going to scoot over so that we are to the left of that intercept. And then we're going to scoot over so that we are to the right of that intercept. We're going to guess within that range, and that's the value of my x-intercept. Question wants us to round to the nearest 10th. So take a look at the number in the 10th place, and then take a look at the number that comes after. Because it is not 5 or higher, we don't need to change the value. We're just going to leave it as 2.1, and then go back and take a look at the units. So the x-axis represents distance. Distance is measured in meters as we're told by the question. So we also need to include appropriate units on there, and that is the distance from the ledge that we end up at. All right, so let's take a look at one final question, and it's a number question. We're told that two numbers have a sum of 10 and a product of 21. So we know that sum is addition. We know that product is multiplication. We have to determine a single variable quadratic equation and then get those numbers. All right, so let's begin with, we're going to choose a variable to represent the first number, and then the second number added to the first number is going to give me 10. So we can go ahead and set that up. So n represents one number, m represents another number. And then we are also told that the two numbers multiplied together are going to have a product of 21. All right, so we've got our two equations set up based on the information we're given, but we need a single variable. Each of our equations contains two variables, so I need to isolate for one of those variables. And it doesn't matter how we go about this, but if you take a look at this, if I isolate either n or m in this equation, I'm going to divide one out, and I'm now working with fractions, which is doable, but not the easiest way to go about this. If I isolate one of these variables, I can just subtract the other, and then I'm going to not have to deal with those fractions. So again, doesn't matter which one we do. Let's say we want to isolate m. So if I want m by itself, I'm going to subtract n, and we can get it down into that. So now what we can do is say, okay, if m is equal to 10 minus n, we can go ahead and put what m is equal to in the place of m. So we have n times m is equal to that, equals 21. We now have a single variable equation, and we can see that when we go ahead and distribute this n in to get rid of those brackets, we're going to end up with a quadratic. I'm going to have 10n minus n squared equals 21. I'm going to rearrange this to get it equal to 0, and I generally want to have a positive squared term. So what I'm going to do is I'm going to add n squared to both sides, which means I subtract 10n. I'm going to bring that left side to 0. None of those are like terms, so we're going to end up with this particular equation. I'm going to now graph it and get two x-intercepts, or in this case, n-intercepts. And now we need to interpret this solution. So if n represents one number, then m, our second number, is going to be 10 minus n. So the first number we have is 3. So if n is 3, 10 minus 3 gives me an m value of 7. If n happens to be 7, then m is going to be 10 minus 7, 3. So in either case, the two numbers we end up with are going to be 3 and 7. And then quickly just verify. Add them together. Do we get 10? Multiply them together. Do we get 21?